Okay, this is section 2.3. Again, this is another review section. Just to remind you, all of chapter 2 is a review. So if you need help on factoring, this is definitely what you want to watch. Okay. So the first thing that we're going to talk about when we factor is we want to factor out the greatest common factor, the GCF. Okay. So we have this example 12x to the fifth, 18x to the fourth minus 24x to the third. Now, I want to take the most I can out of all three of these terms. Now, in this example that they showed, they broke everything apart. And I don't suggest that you do that because sometimes uh, these can be really large. Notice that if you look at like number 3 and you do it like this, you're going to be there a while just to break that apart to find the GCF. Okay. But they do this just to show you how they find it. So what they've done is after they've broken everything apart into its prime factorization, then they go through and pick what is common. So there's a set of twos, there's a set of threes, there's a set of x's, another set of x's, and another set of x's. So our GCF for this one is 6x to the third. So that's what comes outside, and then you write whatever's left. Well, here, since you took all that out, you have a 2x and an x, so that's 2x squared. And here, you took all that out, so all you're left with is a 3 and an x, so that's 3x. And here, all that went away, so that's just a negative 4. And notice that is what is left over. So essentially, guys, what you're doing is once you determine your GCF, you hang on to it, but you just divide those terms by the GCF. Okay. So if we look at number 1, I want to know what would be my GCF. Okay. So my GCF would be the most that I can take out of all of my terms. So 8, 20, 12, and 20. Well, if I took a 2 out, I'd have a 4 left over. That would be a 10. That would be a 6. That would be a 10. So there's still something else I can take out because they're even numbers. So I would take out a 4. All right. So if I take out a 4, that's for the numbers. Now look at your variables. We have an 8, x to the 8th, x to the 6th, x to the 4th, x to the 3rd. Now you might think, oh, we're looking for the greatest common factor, so we want to take out the x to the 8th. Well, this only has 3 x's to give up, and you can't get 8 out of 3, you can't get 8 out of 4, and you can't get 8 out of 6. So the variables work differently, they work opposite. So the GCF for the variable is actually the smallest exponent. But for your numbers, it's the largest factor that you can take out. Okay. So in this case, the GCF for my variables is going to be an x to the third. Okay. Now I'm going to open my parentheses and write what's left. Well, 4 times what is 8? Well, that would be a 2. This has 8 x's. I took 3 of them out, so that means I have x to the 5th left. So 4 times what gives you negative 20? That would be a negative 5. You have 6 x's. I took 3 of those out, so that means there's 3 that are left over. 4 times what gives you negative 12? So that's a negative 3. You have 4 x's. I took 3 of them out, so I'm left with an x. 4 times what gives you negative 20? That's a negative 5. And I took all of the x to the, all my x's out. All right. And this is your answer. All right. That's all you had to do. All right. So if you want to try number 2, go ahead and do that. All right. So now number 2. Now be careful because we have lots of things going on. So first I notice I have a coefficient of a 1, and that right there tells me I cannot take a number out. And 13, 11, and 19, those are prime anyways. So I cannot take a number out. So my variables, let's see. I have a y to the third, a y to the fifth, and a y to the third. So the smallest exponent is going to be this y. So I'm going to take a y out. Then I have an n to the third, n to the seventh, and an n to the third. Again, the smallest exponent I have is a 1, so I'm just going to take out an n. So my GCF is just a yn. Now let's write what we have left. We started out with 3 y's. I took 1 out, so that means I have a y squared. And then I took that n out, so that's not there anymore. Minus 13, I took the y out. I have 3 n's, but I took one of those out, so that means I have an n squared left over, plus 11. Now we took out a y and an n, and I have 5 y's and 7 n's, so I'm going to decrease those by 1. So y to the fourth, n to the sixth, minus, and then the 19, because we didn't take out a number. Again, we took a y and an n out, so I'm going to decrease these by 1, so that's just a y squared, n squared, and that's it. That's the most that we can take out. Okay? All right, let's look at number 3. 13 and 12. I'm sorry, 30 and 12. So if I took a 3 out, that would be a 10. If I took a 3 out of here, that would be 4 left over. So 10 and 4 still have something in common. So I could take a 6 out. That would leave me with the 5, and that would leave me with the 2, which would be great. So we're going to take a 6 out. Now your x is x to the fourth, x to the seventh. We take the least, the smallest variable, the smallest exponent. Now for the y, we have a y to the sixth and a y to the third. So I'm going to take a y to the third out. And then z squared and z to the fourth, I'm going to take a z squared out. All right, now let's write what's left. Let's be careful. We took a factor of a 6 out, so 30 divided by 6 is 5. I took all of the x's. This has 6. I took 3 out, so that's a y to the third. And then I took all of the z's out. All right, minus 12 divided by 6 is 2. I have 7 x's. I took 4 out, so that leaves me with 3 x's. I took all of the y's out. I have 4 z's. I took 2 of them out, so that leaves me with 2 z's left over. And this is your answer. Okay? All right. Now, the next thing, it says, if the first term is negative, we usually factor out a negative common factor or just a negative 1. So that's what we definitely want to do. However, if you can factor more than that, go ahead and do it. So I know I'm going to be taking out a negative because I'm starting with a negative leading coefficient. So 3, 12, and 8, the most that I can take out of those 3 would be a 3. Those 3 terms would be a 3. And I cannot take a variable out of the 18, so a variable doesn't come out. Okay, so the negative 3 came out, so I'm left with an x squared. Negative 3 times what gets you a positive 12, so that would be a negative 4. The x stays. Negative 3 times what gives you negative 18, so that would be a plus 6. And that's it. Okay. All right, number 5. 8. So we start with the negative, so we know we're going to be taking a negative out. All right, so we have 8, 9, and that already tells me that I'm not going to have a common factor for my numbers. 8 and 9. 9, if I split that apart, it's 3 and 3. If I split this apart, that would be 2, 2, and 2. And they don't have anything in common, so that means I know I'm not going to have a number to take out. So now we look at the variables. Y to the fourth, y to the third, y squared, and y. We take the smallest exponent, which is just the 1. So we're going to factor out a negative y. Okay, so now we're going to be left with a y x to the third minus 9y squared plus 3y minus 6. Now, remember when you push the negative through? So this would be, let me pull back where is it? This is from, so going back to 2, 2. So when we distributed a negative through, remember how it changed all of your signs? Well, if you pull a negative out, your signs are going to flip back. So if I pull the negative out, then my signs have to change. So that's why that changed to positive, that changed to negative, that changed to positive, that changed to negative. Okay. And so for right now, we're just getting you used to taking out the GCF. Later, what's going to happen is whatever is left over, that is going to be able to be factored. Okay. Now, number 6 looks a little bit different. And it's actually 5, 6, and 7 look a little different, but it's actually getting us ready for another factoring technique. So understand this is one term. Your plus and minus signs split up your terms. And even though you see a plus sign here, this is part of a product, which means you're multiplying these two terms together. So this is a term. I'm sorry, that's a term, and this is a term. And that minus sign splits up our two terms. Now notice that each of those two terms, they each have this 2x plus 3. So there is a greatest common factor, which is the 2x plus 3. So if I factor that out, look at what you have left. You have a 5x minus 2. And that's it. Okay. Now they only gave you one example, but let me give you another one. So let's take 7p squared times 3p plus 1 minus 5 times 3p plus 1. Okay, so remember, this is a term, and that's a term. And each of these terms have a 3p plus 1. So I'm going to factor that out. And when I factor that out, their coefficients, the 7p squared is a coefficient, the negative 5 is a coefficient. Notice that their coefficients is what is left over. So 3p minus plus 1 times 7p squared minus 5. Okay, all right. Now, number 7 is a little bit different because we do have two terms, but notice that what's in parentheses, these almost look the same, but they're not, because your y is positive here, but it's negative here. Your 3 is negative here, but it's positive here. So we have this expression, b minus a is the same thing. If I were to subtract a negative, if I took a negative out, remember your signs flip. So the b would become negative and the a would become positive, and that's exactly what happened. When you take the negative out, these signs flip. So in other words, here's what we're going to do. I'm going to rewrite this. Now the 3 minus y is going to turn into minus y minus 3. Let me do this. So 3 minus y. All right, if I take a negative out, then that means that's a minus 3 plus y. But I want to flip this around so that I can make it look like this. Okay? So now here's the negative. Well, the negative is going to move in front of that 4c. And then here's the y minus 3. Okay? This looks like 46. All right. So now notice that we have our GCF, which is the y minus 3. So let's take that out. And then we're going to write what's left, which is the 2x minus 4c. Okay, now I'm not quite done because they were tricky about this. Notice here, do you see how you have a GCF? There's a 2x minus 4c, so we have a GCF of a 2. So I'm going to factor a 2 out, which means here's my y minus 3, which means what am I going to have left over? Well, if I took the 2 out of here, I have an x. I took a 2 out of here, I'm left with the minus 2c. Okay, so these can absolutely be tricky. You have to be very careful when you're working through these. Okay, now what this is really getting us ready to do is to use another factoring technique called factoring by grouping. Now you use factoring by grouping when you have 4 terms, and they gave you an example. Okay, so identify and factor out the GCF from all 4 terms. So if you have one, take it out. Then you're going to split it in half. So I'm going to take the first 2 terms and the last 2 terms. I take the GCF out of the first 2 terms. I take the GCF out of the last 2 terms, and notice what's left. Do you see how they have common factors? So there's another GCF that we take out. And when I take that out, I'm left with the 6a minus 5. Okay. Now, I'm not going to color code the way they did that. The way I'm going to do this is I'm just going to cut this in half. Now, let me explain something here real quick because I always see this happen. And this is so wrong. Do not, when you do this, you know you're going to have to split these up into 2 terms. Do not do this. Because if you do that, you change the problem entirely. You cannot factor that. That means you have to FOIL. Okay? So you don't want to do this. All right? So what we're going to do is I'm going to split these 2 terms in half, and I'm going to do this right here. It's going to go right after the second term, but before the sign of my third term. Okay, now out of the first 2 terms, what can I take out? Well, 20, 25, I can take out a 5. And x squared and x, I can take out an x. And then that's going to leave me, I took a 5 out of the 20, factored it out, so that's a 4. I took an x out of my x squared, so that's an x. Minus, I took a factor of 5 out of the 25, so that's a 5. I took the x out, I'm left with a y. So 4x minus 5y. All right, plus, now we're going to do the same thing over here. What can I take out of 24 and 30? Well, that would be a 6. Now for my variable, I can't take an x out. This one doesn't have an x to give up, but I can take a y out. Okay, so now what's left? Well, I factored a 6 out of the 24, so that means I have a 4 left, and the x didn't come out, the y did, minus 5. I took one of the y's out, and I'm left with another y. So notice, when we did this, notice how we ended up with the common factor. When you factor by grouping, if you do not end up with a common factor like this, something went wrong. Okay, and this is your answer. 4x minus 5y times 5x minus or plus 6y. Okay, now I'm going to show you how I actually handle this from here on. So here we go. We're going to cut this in half. So I'm going to factor out of the first 2 terms, I'm going to take out the GCF, which is an x squared. So that means I'm left with an x minus 5. Now, I know, just like over here, once you get this factor, it has to repeat. So there better be an x minus 5 over here. Well, now let's work backwards. Let's work smarter, not harder. X times what is 4? X, and that would be a 4. Minus 5 times what is minus 20, and that would be a minus 4. So that means we can take out a minus 4. Okay, so now again, we have common factors of the x minus 5, and then we're left with x squared minus 4. Now, I don't know why they put this problem in here. I'm going to stop it right here, but actually this can be broken apart one more time because x squared minus 4 is a difference of squares, but we won't get to that until the next section, okay? So we'll just leave it alone for right now. Okay, number 10, if you want to try this on your own, you can try 10 and 11 on your own. All right, cut it in half. So the most that I can take out is an x squared. So I'm left with x plus 8. So that means I'm going to take out a minus 5. And so x plus 8 times x squared minus 5. And that's it. Okay. All right, number 11, we're going to cut it in half. So the most that I can take out is a 5x to the third. And we're left with a 4x to the third minus 3. So 4x to the third minus 3. And the most that I can take out would be a negative 4. Yep. Okay. So again, we have that common factor of the 4x minus 3. And then the 5x cubed minus 4. And there's your answer. Okay. All right, this is going to be key in one of our factoring techniques that we're going to learn later. So you want to make sure that you can do this and make sure that you know how to do it, but that you can do it fast. Okay. All right. So number 12, these are literal equations. So we're solving for y. So y is in two places. So that means they each have a common factor. So if I take a y out, I'm going to be left with a 3x minus 5 equals 10. And since I want to solve for y, then I'm just going to divide. I'm going to divide both sides by this 3x minus 5. Okay. So this is gone. So y equals 10 over 3x minus 5. And this is your answer. Now, be careful. I know it's tempting. You look at that 10 and the 5 and that 5 and you go, ooh, that could be 2 over 3x. Well, no, because this is a binomial. So you are not allowed to split that apart. Okay, this is your final answer. So don't do anything else with it. All right, number 13. I have to solve this for x. For right now, x are on two separate sides. So the first thing I need to do is get it to where it looks something like number 12, where I have my x's on the same side. So what I'm going to do is subtract this 2px from both sides. And then I'm going to subtract the 4a to the other side because I want to get my x's by themselves. Now that my x's are by themselves, I'm going to factor the x out. And I'm left with 3 minus 2p equals 1 over 1 minus 4a. And the next step to solve for x, I divide both sides by 3 minus 2p. Okay. So x equals 1 minus 4a over 3 minus 2p. And that's it. These can be tricky, but the more you practice, the easier it becomes. All right. Let me know if you have any questions.